Yeah, I was trying to put an aftermarket engine management system on it, and everybody told me, you can't do it. It has a CAN bus. You're not going to figure it out.
Challenge accepted.
Yes, absolutely. Challenge accepted. Let's dig into this. And so it drug down this rabbit hole. I didn't know what CAN was in the grand scheme outside of a communication model from the get-go.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Mitch Minton from Minton Performance. Mitch, interestingly, is actually one of the OG HPA members, and we've been friends with Mitch for about as long as HPA has been in existence. And it's been interesting watching Mitch's journey over those 12 or 13 years as he's really developed a passion for CAN communication and really run off to the races with that in terms of what he's doing now with his business. Anyone these days who's involved in performance aftermarket electronics would probably almost need some level of understanding of CAN communications because it is such a powerful communication template in order to send and receive messages from different pieces of electronics. And what this means, it really unlocks our ability to now no longer be locked into the same brand for, let's say, an ECU, a dash, maybe a TCU. Everything really communicates on a common protocol, and as long as we can understand that protocol and send and receive messages in the correct format, then we can mix and match our electronics components. Now, one of the things that Mitch has done with CAN Communications is built his own CAN gateway. He calls it his CAN Triple. And this is an interesting device because it really unlocks a lot of potential that otherwise we just wouldn't have. Mitch actually popped back on our radar after our interview with Tuned by Sean. And the reason for this is that Sean and Mitch have partnered up to provide Haltech Elite plug-and-play solutions for various late model cars. One of these is the Z06 Corvette. Now, traditionally, this would be impossible with the Haltech Elite because the CAN communication template is locked down. It's not user definable, and some of the other electronic components in the Corvette are expecting messages to be sent in a particular format. This is where the CAN gateway comes in. It can take the messages being sent from the Haltech, take those in, and then send them out on the correct address and in the correct format for the other electronics in the Corvette system. Now, I'll admit that this particular podcast episode does get a little bit nerdy at times, but for those who are interested in learning more about CAN, is going to be an absolute goldmine of information in this episode. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day no questions asked money back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools or just about anything in between. They are great prizes and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Mitch. Thanks for joining us. And as we always do, let's start by finding out about your background and specifically how you got interested in cars.
Yes. So thanks for having me on the show. It's a pleasure. Hopefully I can bring some value and entertainment to it. Starting off, I guess the Fast and the Furious really is what sparked it when I was about 12 years old. Before then, I didn't really have much of a fascination or interest in cars, mainly because of my age. It was just more of just a sports kid. But after watching the Fast and the Furious, I thought cars were pretty cool and started, wanting to learn a little bit more about them. And from there, after getting turning 16, so to speak, it became sort of transportation. So the next thing you want to know is how can you fix your car up to make it cooler? Like most every 16-year-old kid, you do all the wrong things to it, and
Currently, I'm staring into my crystal ball, and on the back of the Fast and the Furious, I'm assuming there's maybe Hondas in the background somewhere.
Oh yeah, absolutely. Yeah. My second car was actually an 89 Accord, and it was carbureted. I didn't know anything about carburetors at the time. And I was like, oh man, I can make this thing the fastest thing in the world. No, it didn't really have much option.
The great thing about the Honda world is the interchangeability of everything, though. They are a pretty easy platform to go and buy XYZ model and then upgrade it with B series or whatever it might be. So a lot of plug and play compatibility, which is nice.
Yep. Once I, kind of transitioned over to like the Civic, so to speak, and the newer Accords, that was certainly what sparked the curiosity and fascination of how you can, oh, okay, you can take this, stock Honda and, see cars and, like Tony Paulo's and see him making massive amounts of power on, Street Fire at the time and say, oh, I could do that. And, and start just digging down the rabbit hole of what swaps and what's interchangeable.
Yep. No, that makes a lot of sense. Okay, so you're building up your skill set and knowledge around the Honda platform and your mechanical skills at the same time.
Yeah. So, I never could afford too much for parts or whatnot. I ended up, if I wanted to fix it or modify it, I had to do it myself. So I had some issue at some point where I had a chipped valve in one of the cylinder heads of my Civic at the time. So I couldn't take it to a shop, and they're going to charge me an astronomical amount at the time, and I'm just a broke teenager. So I had to learn how to fix it myself. And so, scary as all get out, replacing a timing belt for the first time and things like that and getting it in time. But there was a few resources at the time that helped me. There's a guy, OmniPower or OmniMan, Steve Rothenbuehler, I believe is his name, built a 200 horsepower NA B16 DVD. I bought the DVD and watched him rebuild this from the ground up.
DVDs, wow.
Yeah, I know.
It's a throwback.
I ended up, figuring out how to fix the Civic and got it up and running and turned it into a little bit of a, kind of like a teenage side hustle, because there was quite a few cars that needed valve lashes as well as valve train replacement because they had chipped valves as well. So as a teenager, I made a little bit of a side hustle doing that and just kept growing on my knowledge base a little bit at a time.
Sure. All right, so at this point, are you considering that cars are the career future for you, or are you still going down another path?
No, so I never looked at the automotive environment. Everybody, when I was in high school, was like, oh, you really like cars, you should go to like NADC or the local, auto diesel college to learn cars. And I was like, I really don't want to do that because, a little bit ignorant at the time, but I was like, why would I go to school to learn something I already understand and know at a decent level? I was like, I just need to go into the field, if anything. And I was also more interested in computers and stuff and IT. And once I graduated high school, I largely didn't have a plan. I didn't go to college or anything like that fresh out of high school. I didn't know what I was going to do. I ended up just working at a local job here and there and doing, just working on cars on the side, making extra cash where I could, and kept just kind of understanding how things work a little bit at a time. Nothing too crazy there. I never actually went to college. I never followed into going to a college or getting some type of collegiate degree at all.
So at what point did you sort of, the penny dropped and you figured out what the path forward was? And how did you sort of continue to develop your skills with computers, IT, programming, etc.? So that's a big part, obviously, of what you're doing now.
I've always had a curious mindset. I never really stopped asking myself questions. It's a very double-edged sword because there'll be plenty of times at night where, now, the search engines are pretty capable of answering questions rather quickly. But, at the time, if I didn't understand something, I would keep digging and not give up, and just, relentless research is essentially what I would do, which sometimes would be, in the era of forums, you would search and try to understand forums and see what people are saying on forums, which is, sometimes could lead you down the wrong rabbit holes in certain aspects. But there's a lot of information out there that was disclosed. So you took it all and made a, educated guess and started trying to understand things. What's the next question you can ask to ask better questions to have a better understanding. That never really stopped.
I don't. Yeah, I was going to say it doesn't stop. That is life now. I think it's changed. The methods we use for research are different. Back when I was building my drag car, YouTube either wasn't a thing or was in its very infancy. It was back to the days of forums. But as you mentioned, you can put any information you like on a forum. Doesn't make it right. And I think there's sort of this implication that if it's out there as a written document, then it must be accurate, which is clearly just absolutely not the truth. It's one of the reasons why HPA exists, is to dilute all of the information. You can learn how to tune a car if you want to put enough time into scrolling forums and YouTube videos. But again, you've got to know enough to be able to decipher whether the information is accurate or complete garbage. And yeah, when you're at the start of that Dunning-Kruger sort of curve, it's difficult to know that. And I think the same goes these days now. Obviously, AI is another tool that's available, but the hallucinations it has are just outrageous. So you can really get yourself in a lot of trouble if you just blind trust ChatGPT, for example.
Yep. No, that's absolutely the case. I mean, I've seen a lot of people that'll post like, Oreo spelled backwards is Oreo to ChatGPT and the GPT model and stuff. It's definitely helped more than it's hindered, but you do have to give it a reality check every now and then. And I feel that if you do ask ChatGPT, hey, is this garbage you're supplying me? It largely will respond back, you know what, you're right. Like I've had to do it a few times myself on, hey, I'm trying to solve XYZ problem, and here's the methods I'm looking at approaching. And it'll tell you, hey, this is, you need to go this route. And I'm like, hey, that doesn't sound right. I want you to reevaluate what I'm saying. And make sure you double check your work, I guess.
Yeah, I think that's exactly right. I mean, when it can tell you, when you challenge it, like, hey, no, I got that wrong. Well, if you know you got it wrong now, why didn't you know you got it wrong before I asked you if you got it wrong? Just give me the correct information. You obviously have it there. But probably oversimplifying what is a very complicated model. I don't even pretend to know what's going on in the background. But the fact that it is so powerful and in its infancy does make you wonder what that's going to look like in another 5 years' time.
Absolutely.
However, I digress. Let's get this train back on the tracks. So I guess give us an abbreviated view of your work history and what you've done to bring us up to speed to current day.
So out of high school, I just worked, normal jobs. Eventually got a job at a factory, nothing largely related to the automotive field, because I didn't want to also get burnt out, because I noticed a lot of people that would, go and work at a dealership or, automotive environment. They largely grew to loathe the atmosphere. So if they wanted to work on their cars and enjoyed it, they would get burnt out relatively quickly.
I can confirm that is a real thing. I was actually talking to someone earlier today about this back when I was running my old shop and building my drag car, and after spending 40 to 50 hours during the week working on customers' cars, and then in the nights and in the weekends I'm sort of spending about the same amount of time again trying to get a drag car built or fixed or whatever it was. After 6 or 7 years of that, you sort of it wears thin. And I did find for the longest time that I just lost that passion for working on my own car, which is now nice. I get to step away from that so that passion comes back.
Yeah, absolutely. Yeah, I knew that would be the case if I tried to jump into the automotive workforce. So I didn't do that. So if I wanted to go to a job I hated, I wanted to make sure it wasn't in the automotive field, which I did for quite some time. I eventually got a job building tires at a factory. And this is where I started digging into essentially your courses and courses all across the country that I could take. I basically went to every automotive training seminar for the automotive aftermarket that I could. So anything that was offered on the East Coast at all, I've basically taken. And that helped, I guess, drive home the model of understanding that it's, engines are subject to laws of physics, and everything that is going on is associated with physics in some regard. So there is no magic. So it's like just peeling back the veil of the secrecy of things and just starting to understand them more and more. I just kept digging into, and I never really stopped.
Yeah. Okay. Now, you were, I think, actually one of our fairly early adopters of our courses. Do you have an idea of kind of what year that was?
I think it was 2014, 2015.
Yeah, okay. So we're circa 10 years ago now.
Yeah.
Okay, and can you, I don't want to, this isn't a paid ad for HPA, but just we don't get to talk to too many people on the podcast who have taken the courses. I'm just interested if you could give us a high level view of what courses you took and how you found that information. And then also if you can give us a comparison between how you found learning from an online platform versus in-person training.
Yeah, absolutely. So the first course that I took was the wiring introduction and the beginners to wiring course. At the time, it was Ryan Rywire, which is what brought it into my light and understanding like, oh, okay, this has got to be a good course because it has Ryan on it. Ryan's like this trademark of the Honda scene. It's definitely got to be great, and it certainly was. And I learned a lot from it, and got a better understanding of ampacity and current limits and things like that based on wires and grounding and stuff. And then I followed that one up with the understanding traction control model because I didn't understand enough at the time. Granted, I didn't have a real need to, because I didn't have a standalone engine management system or anything I could really play with traction control on. But I was like, I just want to understand how, because in the drag racing world, your 60 foot's going to be a make it or break it in most circumstances. So if you don't have a solid launch, you're not going to make it.
Yep. Okay. And just again, that comparison between online learning versus in-person. I mean, obviously, everyone learns differently. Some people will respond better to one method over the other. I'm just interested in your personal takeaways.
So online versus in person, the benefit of in-person training is you end up building relationships with, the peers in the class as well. And which is, it's helped me, develop better, understandings on things because I can relay on them for stuff that wasn't directly talked about in the class as well. Because I've went to training with people that worked at drag diesel performance shops. And so like the diesel stuff is still, it's still outside of my realm of understanding. But I was like, hey, like, how does this work with the diesel side? And they could, they could explain it to me. So you build relationships that you don't necessarily have online. But also the online space offers typically it's a whole lot better value when you're looking at it of education and knowledge per dollar, right? Because the scalability of it, you can only fit 30, 40, 50 people in a classroom and you can only handle those once a weekend, at best, right? Versus online, it did offer more value. So it's easier to take online courses over and over and over again. And that's, largely, I've subscribed to a lot of online educational and learning materials for that specific reason, because you get a lot for your money as well.
One of the benefits, as I said as well, is I've obviously taken a lot of in-person training courses over the years on a huge range of different topics. And often you kind of go into a 2-day or like a weekend course and you kind of get smashed with so much information. And at the time you're retaining, most. And then a week later, you're trying to remember everything. And then 2 months later, I think it is nice with the way we operate our courses, being able to just go back and review it. Once you buy the course, it's yours for life. So, I like to sort of suggest to people, hey, you take the course, and then when you're actually on the dyno tuning and you're doing a particular task, you can go and rewatch, a module on ignition timing or F fuel ratio or whatever, and really cement that knowledge and make sure that you're doing it right. Yeah, so I mean, again, pros and cons of each method. Obviously, this is the one that's worked for us. It's much easier for us to scale. There's only one of me, and it'd be very difficult to be flying around the world hosting these in person. So kind of really just wasn't an option.
One of the instructors said it best. This weekend, you're going to be drinking through a fire hose of knowledge.
Yeah, that's an excellent way of looking at it. I guess as well, like it depends on your current level of knowledge on whatever the particular topic happens to be. If you're already semi-proficient with it, the fire hose might turn down to maybe more of a light stream. But yeah, when you are coming in fresh, and you're just going to be bombarded left, right, and center.
Absolutely.
All right, so before we started recording, you mentioned that you also got involved in some sort of race engineering data analysis. So give us the rundown on how that all came to pass.
Yeah, so essentially it's kind of odd, but I got a random message on Facebook, and the guy, he lived in California, and he told me to literally, he said, can you meet me at a shop in your area on this date at this time? And that was it. That was his question. Hey, I've got work for you. Can you meet me at this shop? And I'm looking at him. He seems that he's race oriented. He's like, I got to work on a race car. That I want to see if you can solve a problem for us. I've seen your skill set, and I'm curious to see if you can answer a question for us. So I said yeah, and I show up. I end up showing up at this shop. This is mid 2018 era. End up going there and walk in, and they have an Audi R8 GT3, and the guy asks, I need you to find oil pressure on this car. We don't have access to all of the equipment. The Bosch data logger's locked, and we can't infiltrate it. We can't log into it. We don't have the tools to do that. But we believe oil pressure is on that car, and we want you to find it so we can add it to our Motec dash that's an ancillary dash in the car.
You would certainly hope that oil pressure existed in an R8 GT3.
You would hope. Unfortunately, I went through like essentially a line by line analysis and told him, I don't believe it's here.
Wow.
And we did a case study, and I was like, all right, so we have to basically model it. Car's cold. I want to log all the messages cold and analyze, a signal that was high at start, that was, basically off when the engine was off, started high once we started the engine. Once it warmed up, tapered off and down. And then that would be one log. And then another log we're going to start it again. I expect it to be low. I want you to roll slowly into the throttle. I expect it to raise. And I want you to roll out of the throttle. I expect it to drop. And then I want you to stab just 3 times lightly, see if we can see a small jump. After analyzing all this information and spending, 2.5, 3 hours there, just walking through all of the messages line by line, I basically said, I don't think it's there. And the guy kind of scoffed me off like, well, I thought you would be able to do it, but, whatever. And so that was it. It didn't hurt my ego. I felt concise that it was not there. And I got a call about 3 weeks later, and he said, hey, we were able to log into the Bosch, logger that has the oil pressure sensor on it. And you were right. And it's impressive that you were able to tell me that it wasn't there.
All right. So let's just sort of break this down, because this could be quite confusing for a lot of people. So first of all, I'm assuming here you're talking about and logging all of the CAN messages that are being sent from the engine control unit to the Bosch data logger.
That's correct.
Okay. So on that basis, if it actually does have oil pressure, I'm assuming that was a direct wired sensor for oil pressure direct to the dash, as opposed to the ECU and then being transmitted via a CAN message. Is that how that works?
That is exactly how it was working.
Because I was starting to get really worried that this $900,000 GT3 race car didn't have oil pressure monitoring, because that would be scary.
It was there. It just wasn't actually transmitting on the specific bus that they said that it would be on going to the Motec dash.
Okay. Well, it's always nice to kind of have that backup that you were right when you start questioning yourself too.
Absolutely. Yeah. And especially in a circumstance like that, it's like, I didn't have any, like skill set, or like, there was no like, oh yeah, this guy's done a lot of work, elsewhere. It was just, hey, this guy's in the area. Let's give him a try.
But bit of a side quest here, that if you're sort of not running a shop and you're not that well known, how did these guys actually find you and know that you kind of had this skill set?
So I'm pretty vocal on Facebook, sometimes for good and bad reasons, but mostly for good. I ended up posting a lot of my explanations and videos on Facebook and YouTube, and explaining how to analyze CAN bus messages in certain regards on YouTube. Those videos are quite dated now, but at the time, I was like, hey, this is how this works at, I was kind of at the little bit of the bottom of the Dunning-Kruger hill in some regards, but hey, here's all these messages, and these messages come through. And if I press the gas pedal, RPMs increase, and you see these digits go up from left to right here. And yeah. And so, did I understand it a little bit deeper? I did, but I wasn't the best communicator at it. But at the same time, it was certainly a new era of information, and I wasn't as adept as I would be now, so to speak.
Sure. Yeah. I mean, obviously these skills do continue to develop, and the more you do, the better you get at it. All right, so that was sort of a bit of a hit and a miss on that one, but no fault of your own. How did that continue to get into doing this data engineering, race engineering?
So COVID hit. Once COVID hit, largely the whole country shut down for about 3 months. So racing wasn't going on for 3 months. And I can't say for exact, but I do know that most of the racing sanctions, you have IMSA, you have SRO, you have Trans Am. NASCAR's in its own little world. They don't really care what everybody else is doing anyways. But your SRO and your IMSA races, they typically aren't going to fall on the same weekend. And Trans Am tries to do the same thing as well, because largely you'll see a lot of overlap between IMSA teams, SRO teams, and Trans Am teams trying to run on different weekends. So one weekend will be SRO, the next weekend will be IMSA, the next weekend will be Trans Am, and they may have a week off. And so once the schedules got shifted and moved around, they were all overlapping each other. You couldn't make both events. So all of these racing teams were sitting there having to make, choices on what events they're going to go to, because now they have so much overlap. So the guy that had called me he worked as a data engineer and DAG, so to speak, for this team that I had showed up for this Audi R8. And so they actually reached out to me and said, "Hey, like, we can't get the guy that contacted you to, come in here. You seem like you know your stuff. You've taken all this training. Do you think you can make something out? We're taking a risk, and we want to see if you're able to, meet our needs." And so I said, "Sure. Yeah, why not? It's worth doing. I like cars. Let's go."
Yeah. You're sort of definitely jumping in at the upper echelon, or towards the upper echelon of data analysis as well, working in a GT3 team.
Yeah. It was largely a jump into the lion's den, right? And the colleagues that I was working with, I mean, there's some pretty stout resumes, from Porsche Motorsports director for 30 years to Corvette racing director for 28 years, that I'm working side by side with as this time progresses. But yeah, it was quite interesting once I had jumped in, because my background wasn't a padded resume of all of this racing experience. It was largely none. It was just, I understand this data really well.
Yeah, sure. I'm interested with that particular car. You mentioned that it has the Bosch factory fitted data logger, and then they had fitted this auxiliary Motec unit. So what was the drive behind doing that? Are they not versed with Bosch, or what? Yeah,
I think it was a little bit of not adept with Bosch. The car came with a secondary logger. They've added an ADL3, and I think it was equipped originally with a DDU8. So they wanted more sensors, and the ADL3 had the sensors to equip more information. So they added the ADL3, and they used the ADL3 as their base data logger, and they didn't really work with the Bosch DDU8, which worked in my favor, because I had taken Motec's training to understand, data analysis within the Motec systems. It also had a RaceLogic VBox HD2, which was brand new to me at this time, and I had to actually troubleshoot why we were getting lap times only half of the time. Ended up being that the auto track map was picking the wrong track and the wrong layout, and we were never going through the start finish line once it chose the incorrect track.
Well, I'm interested, why not just do your lap timing within the Motec?
So it does bring a good point. The data analysis with Motec, or with the Motec dash, would certainly be more beneficial. The VBox, the RaceLogic VBox HD2, it had basically 2 channels of video associated with it. So if they're wondering what's going on track, we could see out the front and look at the driver to see what the driver input is. So we had one camera going out the front windshield, and one camera facing almost directly on the driver to see what his hand position is, where his feet are, to give him feedback and clue him in on where lap time could be improved.
Yeah, fair point. It's quite often you look at data without video, and a particular lap will be slow in one sector, and you think to yourself, why are you on the brakes here? And then you talk to the driver, and the reason he was on the brakes there was so that he didn't hit the car in front of him that's running slowly for whatever reason. So yeah, video definitely does give you just that extra dimension of understanding the data. So now we've got a car fitted with 3 separate data centers essentially.
Yeah, absolutely. Yeah, I mean, we had live telemetry as well. When the guy, his name was Brad, would show up with us too, he would put telemetry on the car so we could watch the VBox video in pits to, understand what's going on in the car as well.
Wild. How do you find it is to adapt between different systems, let's say the V-Box and the Motec, for example?
Largely I tell people it's experience driven. I will tell everybody, no matter what system you use, learn the hotkeys and learn how to utilize them as efficiently as you can. And anybody that's done any level of tuning probably understands that quite well. Getting through data efficiently and effectively using hotkeys it'll almost separate you from, struggling. I also tell people to make sure your workspaces are set up, make sure everything's set up the way you would like it or the way the driver would like it, way it should be before you get to the track. So you're not chasing your tail a little bit on how to get, more information that they're looking for on the video overlay perhaps, or on the data page that they're looking in, the data analysis system.
Yeah, I think setting up your worksheets for a particular task is really important. So for example, I'll have one for engine, and that's just got the engine vitals, and then maybe another one that's going to dig a lot deeper into fueling in more detail, then another one for chassis and driver performance, so we can focus on what we want to look at. And I mean, generally with a developed race car, other than a cursory glance over engine vitals, we're probably not doing any sort of down in the weeds tuning. It's more really about, is the engine going to start and run for the next session, or are all of the conrods currently hanging out the side of the block? If the conrods are hanging out the side of the block, optimizing the camber on the front right is probably not that important. It just doesn't matter anymore. The other thing I find really important with analyzing large chunks of data quickly, so we can sort of see trends or potential problems without having to go through every lap, is using channel reports, so we can sort of see minimum, maximum values for, let's say, oil pressure, oil temperature, engine coolant temperature, and minimum, maximum, average, and kind of at a glance, this sort of is a go, no go. These are all within in bounds that I'm happy with. Cool, we don't need to look at those anymore. So that takes what could be several minutes of work into something that's literally a few seconds glance. Is that something you also utilize?
Yeah, absolutely. In fact, my worksheets were largely set up. There was a group of about 5 people that would ask questions of me post session, like, hey, well, what was the coolant temp? Engine guy wants to know engine vitals. Gearbox guy wants to know gearbox vitals. Suspension guy wants to look at histograms. Things of all these things just overlaying on top of each other. And as soon as we pull the car in, they all want to know the answers first, right? So it was a little bit of a challenge at first to have an understanding, but as time went on, I eventually set up pages for each individual person to say, hey, like, here's your gearbox page, and I actually labeled them all to their names, so they don't have to question which tab to click on. And it works beautifully, because if they needed something, I left my laptop on the workstation, and
just take yourself out of the equation.
Absolutely. I get the data, I set it up, I let the laptop run, and I let them fight for the mouse.
If you're a fan of the podcast and you're interested in topics like engine tuning, automotive wiring, performance engine building, 3D modeling in CAD, or anything else in the high-performance industry, I have something that you might be interested in. Introducing the High Performance Academy VIP package. This package of courses gives you lifetime access to all of HPA's online training for one price. These courses cover everything from tuning and reflashing petrol and diesel engines, through to motorsport wiring, engine building, fabrication, design, car setup, and plenty more. Right now, you can get $500 off High Performance Academy's VIP package using the code podcast500 at checkout. Becoming a VIP means you'll never pay for another course again. You'll get instant access to all 40 plus courses we currently offer, plus every new course we ever release in the future. Want to define maps or tune with WinOLS? Curious about CAN bus devices, or how CAD can help make your dream build a reality? These in-depth topics, as well as many others, each have their own dedicated course that are going to help you master whatever it is you want to learn. And as a VIP member, you're not just getting the courses, you'll also join HPA's online community with lifetime access to our member forums and members' webinar lessons. Again, the code is podcast500 for that $500 discount. Just head over to hpacademy.com to check out the full VIP package and everything it contains. All right, let's get back to the episode. So how did this all play out? Obviously, you're not doing that task anymore. So talk to us about how that all played out and how far you got through it and why I guess it came to an end.
Yeah, so essentially, I did it for about 3.5 years. When teams change ownership and change people, just kind of you're going to have essentially a revolving door in some regards. If once a name changes, once an entity changes, once a crew chief changes, things like that, they're going to want different people that they're more comfortable with in the position. So I ended up mid-season getting essentially exited or terminated from one season, and then tried to fill it in a little bit, and work was too sparse mid-season, so I ended up going back to a full-time job locally. I was doing a little bit of hybrid work as well. So like Bridgestone, where I was working, had a work schedule that you work 7 out of every 14 days. So what I would do is just stack my 7 days together and then have 7 off, so to speak, to go work on the racing stuff. So I had the stability of a full-time job.
But flexibility as well.
Yeah, and it worked out pretty well. I eventually tried to walk away from it because I wasn't in agreement with where Bridgestone, the company, was taking the building and all the workforce there. Anyways, they were driving it into the ground a little bit, and unfortunately it shut down here recently. But I could see the writing on the wall that it wasn't going to exist, and I wanted to take a leap of faith. The leap of faith didn't work out that well because of how sparse the work was. It was a little bit of a challenge. So I ended up just jumping back into the local workforce, ended up in the automotive field finally.
Oh, there we go. There's the connection. And what does that current position actually look like for you?
So I do mobile diagnostics and programming for a lot of body shops and repair facilities. We'll get calls. I work for a firm. We get calls when they just give up on a car almost. If they don't want to solve it, or they've tried their efforts and they just can't figure it out, they'll call us. We diag it, we address problems, we do all the programming. We have all the OE tools to program it from in the manners that the OE wants and sometimes needs, and essentially get cars calibrated and programmed at most of the body shops and some of the local repair shops.
Okay. Without sort of going too far down the rabbit hole here, could you give us sort of maybe a case study of what that actually looks like? I mean, on face value, I'd think you crash a car, you break some sensors, break a headlight or something. Great. You buy new parts, you put them on the car, and the car goes again. But with late model cars, that's not always the case.
No, unfortunately not. There's a handful of modules on most cars. Front radar sensors are probably the most common for damage, as well as blind spot monitors on the back car. So your indicator on the far corner, once your car gets crushed in the back end, it probably isn't going to be stable or working or operable anymore. And unfortunately, they're just not a plug and play affair. It's not like you can just grab another new one and put it on the car and they typically work. Most of them have their own programming and configuration. The OEMs they'll probably use the same part on many systems, but they say, hey, we want it to be applicable to this model and we expect it to be this configuration.
Okay. Yeah. So just coding it to the individual car that it's fitted to, so that it knows what its job is on that vehicle, as opposed to another completely different vehicle it may also fit.
Yep, that's it. And sometimes it's alignment and making sure that it's all in line. So, you're not, when you're, a lot of adaptive cruise control is on many vehicles. And if it's not set up right, it's going to be looking at the car to the left or the car to the right in another lane. And
it could end badly.
Yeah. And it's not going to be well. It's not going to end well for most circumstances. So you want to make sure that they're squared up and centered up.
Yeah. Okay. All right, we've got that. All right, let's sort of dive deeper into something we've touched on already, which is CAN messages, which is, I guess I call it one of your specialties. I don't know if you'd call that your specialty, but I think that's why we've got you here anyway. So let's crack into that. I mean, CAN, I think, is something that scares a lot of people off when they're trying to communicate between different modules from different manufacturers that are all communicating via a CAN bus. But I think let's start at the high level in what is CAN.
I typically explain to people that have never understood CAN. CAN is a wired CB radio. So if you have a bunch of people on a CB radio and you try to talk while somebody else is talking, you're not going to get through because they already are speaking. And that's essentially how I explain CAN to anybody that doesn't have any knowledge base on the topic. It's essentially it's a communication model that a lot of manufacturers use. It's pretty easy to work with. It's cheap. It's super effective, and it has enough bandwidth to get most of your information through without issue.
Okay, so it's a communication protocol that OE manufacturers are using to send data or messages between different modules within a car, which is obviously our area of interest here. That's a reasonable way of explaining it. So it's the wired CB radio. So the wired part is important. Talk about the physical bus itself. What does that consist of?
So it consists of typically two wires. You're going to have a CAN high and a CAN low wire. Those will run to each individual node almost in a hopscotch fashion. They call it a bus topology, but you can run it hopscotching from point to point without issue. And so at the end of both nodes, or at the end of this network, you're going to want two 120 ohm terminating resistors to essentially say, hey, these are the ends of the network. So you have the end of the network on one side, the end of the network on the other side. And that's what helps essentially the robust nature and how effective the network works.
Those terminating resistors as well, these can absolutely make or break the network. I've probably lost count of how many times I've encountered CAN bus issues, and it has come down to a terminating resistor problem. As you mentioned, these are 120 ohm resistors. Sometimes we're physically adding a resistor across the CAN high and CAN low wires, but other times, a lot of the nodes or modules that we use now have either hardware switchable terminating resistors, or even switchable in software. So you can get yourself into a situation where you think you've only got the terminating resistor at each end of the bus, but one or more of your modules that are on the bus actually also are introducing 120 ohm resistors. So that kind of brings the whole bus down, right?
It doesn't have to bring the whole bus down. If I have to err on the side of caution, I always tell people, if you have more than two, if you have one in the middle somewhere, chances are you're going to be all right. Now, with that being said, if you ask the SAE standard or the ISO standard, they're going to tell you all bets are off. But I've played with enough of each network topology. It's going to be based on a handful of factors. The biggest factor is how many nodes are on your bus and how long that total bus is. And then the third one is essentially how long are the branches off of this network if you're not hopscotching and running a hopscotch fashion. If you have these tree branches that are super long, you can have issues. It's ultimately always a challenge if you don't have enough terminating resistors. So if you're testing something that's 2 feet away, you can sometimes get away with zero. You don't have to have any termination resistors, and you go, oh, okay, it works fine. And then you put it in a car, and if you have no terminating resistors, all bets are off. It just does not want to work.
I think the generally accepted rule is if your bus is under 2 meters long, you can get away with a terminating resistor at just one end of the bus. And I think then the other one is if you're running a trunk style bus with the nodes coming off it, I think the recommendation is that the run from the central bus out to each of the nodes should be 500 millimeters or less.
That sounds accurate. I tell people if you can keep them under a foot, you're good. Now, I'm quite lazy in the circumstances on most of my test models, so I'll test things and say, hey, like I can make a lot of things work that you probably shouldn't. I've had 12 devices on a bus that's essentially hopscotching through, and each branch is close to 3-4 feet long. No problem, but it's also not being put into an application in a critical nature. It is only on a bench. But you can get away with a lot. But I tell people, how far are you wanting to figure out what you can get away with before problems arise?
Well, that's the thing, particularly if you're incorporating a CAN bus into a pretty complex wiring harness, and more so if that wiring harness is a sealed harness with DR25, let's call it a race spec or a mil spec harness. It's very difficult to come back from that if you've got a problem. So there are industry best practice standards for how to construct a wiring a CAN bus, I should say. So let's absolutely do that. And then if we find that we've got problems, well, you can sort of rest easy knowing that it's not because of the way you laid out the bus itself. But you're right. I think there's the industry best practice standards, and then there's a lot of leeway which will still work, but maybe and maybe not. So I like to sort of not have that hanging over my head. Will it work? I don't know.
I tell people if they're working on a mock-up and they want to see if it works, just try it. But understand that there's a spec for a reason.
Definitely, yeah. All right, so we haven't also touched on the fact that the two wires, the can high and can low, are twisted. What's the purpose with the twist?
So the twist is to basically, it increases the shielding nature of it. A lot of your Ethernet cables are twisted for the same reason. It prevents EMI from being able to inject itself as much. 2 twists per inch is the standard, I believe.
Yeah, again, I think that sounds about right. You sort of get to a point, you do this stuff all the time, and you're not sort of going back and checking the standards. So for those listening, and we say 500 millimeters, I think, that's it's not something I'm probably looking up every time. And as well, the two twists per 50 mil, give or take. You sort of.
I tell people, keep it between your wrist and your elbow, and you'll be all right.
Yeah, sure.
That's your branch length.
Yep. Okay. Cool. What if we were to actually scope the can high and can low wires? What are we going to see in terms of what the voltages look like, the signals look like?
So you're going to see essentially 2.5 volts at dormant for both can high and can low. So if you have no traffic on your network, you'll just see this, you'll see can high sitting at 2.5 volts and can low also sitting somewhere around 2.5 volts. It's not exact, but it's close enough. Once you have a dominant bit, you'll see it drive up to 3.5 volts on can high and drop down to 1.5 volts on can low. There's a little bit of discretion there, especially there's this thing called an ACK flag that happens on the network. You will see a little bit of ringing on that. So you'll see a spike at one point in the message, most likely, if you were to put an oscilloscope on it, and see all the ACK flags dropping at the same time. So they create a little bit of a ringing nature on the ACK flag. But outside that, you're going to see 2.5 volts plus or minus 1 volt based on can high and can low.
Okay. Why, if they're sort of moving in different directions, it almost sounds like we could get away with just a single wire. What's the purpose of the voltages moving in opposite directions from that dormant 2.5 volts, give or take?
So essentially it's a differential signal protocol, and they can look at each other, and there's basically a comparator circuit that determines if it is high and low. So if you take one of the signals and essentially pull it off, it may work, it may not. I wouldn't recommend it, but you can essentially run a single wire. It's called single wire CAN. You can run a single wire and run it up to about 250 kilobits per second. It's at a much lower bandwidth than you would have with conventional CAN, but I'm sure we'll.
Yeah, obviously it's not something I'm recommending. Just sort of getting the full picture on that. All right, so we've sort of mentioned length and number of nodes, and just again to clear that term up, any module that we're placing onto the bus is technically referred to as a node. So that might be an ECU, it might be a power distribution module, maybe a CAN keypad, or anything else that you can imagine. Is there a technical limit to the number of nodes or the bus length?
There is a limit spec'd for 40 nodes per network. And that's what I would say. If you've got more than 40 nodes, I've got more questions for you on why they're all on the same bus, to be honest. I wouldn't recommend putting 40 nodes on a network. I would try to keep it, sub 20, to be honest. But yeah, 40 nodes per network. Total branch length, I think, was 40, or total network length, I believe, is 40 meters on a 1 megabit bus. I'd have to look up the specs.
That's close enough. We don't need to get too down in the details with it, but there or thereabouts. And I mean, obviously, that's enough to loop around your car a few times. So not something that's going to be a problem for an automotive application, right?
Correct.
Okay. Let's talk about, I guess, the benefit of CAN. So it's an OE protocol, and they use it so that there's a central bus, or often multiple buses, and all of these devices can talk backwards and forwards on this 2-wire bus or multiple 2-wire buses, as opposed to each individual module in the vehicle needing multiple wires going to the different computers or whatever that it needs to talk to. So that first point I would say is it simplifies the wiring harness design greatly.
Yes, it absolutely does. Like, for instance, if you wanted oil pressure, from your car, right? If your dash needed it to show you oil pressure, as well as the engine and transmission, body control modules, anything that wants to say, hey, we've got a problem here and we have a redundant check, we're going to say that there's a problem, right? Any sensor that needs to be communicated in any manner across that network, you now don't have a physical wire attaching, you know, that sensor to that physical device. So there's a lot of redundancy associated in the networks on OE applications, but you'll end up finding that if you have an issue with one sensor, you might have 7 nodes tell you have a problem with that sensor because they say, hey, we are not happy with that sensor.
They're all relying on that information.
Yep. Yeah, signal implausible, and now I don't know what to do with it. So if I can't determine how much airflow is going into the engine controller can't determine how much torque it's making. The transmission controller don't know how much pressure to run. Things like that.
Yeah. A really simple example of that simplification of the wiring is these CAN keypads that are pretty commonplace. Blink Marine and Greyhill would probably be the two predominant ones that we see. So they can be, let's say a 15 key keypad, and each can have 4 states, I think, maybe.
3 states.
3 states, okay. And, you've traditionally to do that with a 15 switches, that's a lot of wires that you're going to have to run to your device, dash, ECU, PDM, whatever that may be. Now we're down to 4 wires, CAN high and low, 12 volt and a ground. So it dramatically simplifies that wiring, which I think just as well as in the OE world makes our life a lot easier in the aftermarket world as well. The other aspect that I've seen is a real benefit, and what I leverage highly though, is because this CAN protocol is standardized, and these aftermarket ECU or aftermarket electronics manufacturers have adopted it. Now we've got the flexibility to run, let's say, a Motec ECU with a maybe an ECU master PDM or PMU. Maybe we want, I don't know, maybe an Mtron dash. And, you can mix and match all of these units, and it just works, well, seamlessly.
That's the benefit. It's a fairly agnostic protocol, so it doesn't require you to have, proprietary. Oh, you have this this dash. Well, you have to have this, and we're running it all via CAN. No, that's usually not the case. Now there is some constraints and limitations associated with the standard in some regard. Some people do things a little bit differently, but for the most part, yeah, you can take information on various applications or from various manufacturers and make them all coexist on the same bus. It's really awesome. I mean, I do a lot for people doing OE integration solutions, as well as trying to do retrofitting of OE sensors, right? So like, how many cars have a factory IMU in them? Well, most of them do, because they typically are running it to control the analog braking system on any newer application. And even then, they're on motorcycles to have wheelie control. So it's like, okay, let's find these sensors used and see what we can get, because if you want to buy one new, they're IMU from Bosch is what, $500, $600, $700. How much is one on eBay? 40, 50, 60. So let's see if we can start integrating some hardware that we can find that's not broken, but it's just used, and see if I can make something out of it and do a little bit, kind of keep the cost down a little bit associated with integrating some hardware into a project.
I think for a lot of people, the sort of where we're going to go with this conversation about getting down in the weeds with actually decoding CAN and what makes up a CAN message is going to go over a lot of people's heads. And I think that's absolutely fine. When we're talking about integrating different aftermarket electronic components, the benefit is that these manufacturers know that it's in their best interest to make their product compatible with the widest market possible. So for a lot of these products, let's say dash versus ECU, for example, most ECUs will have a CAN template that you can just select that sends out a generic data stream of RPM, throttle position, coolant temperature, everything that you would need to display on a dash. And then you take your dash that's from a different manufacturer and you select the template for Motec, Link, Haltech, whatever the ECU is. It just decodes all of that data. There's no heavy lifting. We don't need to actually know about CAN in order to make those two components work. That's not always the case, and for the most part, I think that's everyone's trying to make their product as compatible as they can. Let's get a little bit more into what a CAN message actually looks like. So can you give us sort of a rundown on that? This is going to be a little difficult as well without the benefit of some sort of visual cues, but do your best.
Yeah, no worries. It's essentially, I tell people there's two parts of the message that matter. You have your arbitration ID and you have your data. There is a data length packet and there's some other things that help the network work, but none of those are really too important. Essentially, the arbitration ID is your message address. It's essentially the same thing like your physical address for your house. It needs to know it is a number to tell you where you are on that street. And each node doesn't have just one of those. It can have as many as it needs in order to communicate information. And then the data packet has your information that it is being supplied for that information for that address. So if you have essentially an address that is from the ECU, you may have engine speed, throttle position, coolant temperature,
dozens of others, potentially.
But it essentially the addresses typically stay static for the information, so that you don't see it like, the address was 1 2 3 for this information, and now it's 4 5 6 once time has passed. That's usually not the case.
We know that if we're looking for throttle position information from the ECU, that is going to be on a specific address, and it's always going to be on that specific address.
That's correct.
Okay. So the data, though, it's not just limited to, let's say, sending out throttle position on a given address. We can incorporate more data than just one message.
Yep. Yeah, you can incorporate essentially as many messages you need. Now, that has a limit. If you're talking the maximum data rate that CAN has, it's 1 megabit. You can essentially fit almost 8,000 messages on that bus at a full payload, which is 8 bytes. That is essentially 8 numbers between 0 and 255 in decimal that we can supply 8,000 times a second. And that is for every device on that network total. And that would be the total bandwidth.
Okay. I think what I was getting at more there is, let's say we've got a specific address. So each of those addresses can transmit 8 bytes or contain 8 bytes of data.
That's correct.
Okay. So within that, we can choose to send multiple pieces of information across those 8 bytes. So for example, we might split that into 2-byte messages. We might send RPM as a 2-byte message. We might send coolant temperature as another 2-byte message, etc., until we've used up those 8 bytes. So you can have more data in that one address is what I was kind of getting at, correct?
Yep. Yeah, that's absolutely correct. You can have, essentially I tell people, you can have up to 64 on-off states in each message.
Because that's another point. We might be talking about a status flag for something. Maybe is the fan on or off? So that can be a single bit of data.
That's correct. Yeah, you can fit 64 on-off states on a single message. If we have messages that don't require a lot of resolution, I'll use coolant temp. Right, our coolant temp, it only needs essentially 1 byte for it to run, because we're not really running it in a spectrum that's super wide, and typically we're going to run it in a Celsius format. So we can say the minimum number is, let's say, -40, and the maximum value would be 215. Well, that would fit in 1 byte. And that's all it would take is 1 byte. And now we have 7 left to do whatever else we need to do. But if you have something like engine speed, you're going to need more space, because the step point you're going to use is going to be greater than that, 255 steps you have per byte. So engine RPM, I don't know how many steps you really want, but if you want your steps to be 1 RPM equals 1 bit, you're going to need probably 12 bits to get everything taken care of on most applications. And then if you just round it off, you just take it to 2 bytes, which is 16 bits.
All right. So to sort of demonstrate this quickly, because I know this can get really confusing really quickly, I just actually prepped a couple of examples of exactly this. So the resolution that we need for a particular signal versus how we would decide to send that data. So kind of slightly different to what you've just said there. Let's say we've already talked about the fact that 1 byte is 0 to 255. So that's our maximum range. So the example I used here was throttle position. Obviously goes from 0 to 100. So if we're going to send that out over 1 byte, we basically divide our range of our throttle position, which is 100, by the maximum number of our single byte, 255. And if we do that, we find that rounding each step the resolution each time we step up our throttle position is going to be 0.4%, which probably for most instances going to be just fine. But if we look at a signal that's going a wider span than just 0 to 100, and RPM is the one that you used, and I also used this, let's say we need to span from 0 to 8,000 RPM. So if we use the same little example there, divide our 8,000 maximum by 255, and that gives us each increment, each step is going to be 31 RPM. Probably for some cases that's going to also be just fine, but for others that might be a little bit coarse. So then if we go from 1 byte to 2 bytes, instead of our maximum value being 255, we're now up to 65,535. So it steps up really quickly. And now if we do that same calculation there, 8,000 divided by 65,535, now we've got a step size of 0.1. So hopefully that just demonstrates how the resolution we want versus how the information is encoded is important. And if we look at something with a lot of resolution required, GPS for example, if you're looking at your latitude and longitudinal GPS coordinates, those are huge numbers. So those are typically going to be encoded over 4 bytes to give us the resolution we need. Otherwise, the data's sort of not really useful.
Yeah, your step points will be way too big. It'll show you, essentially in one state, and then your next step would be the next state over, province over.
Yeah. Now, I don't think we need to go too much further into bits and bytes. Hopefully, that's enough. Just understanding that essentially, one byte is 8 bits. Each of the bits has the ability to be either 0 or 1, on or off. So if we go from all of them off, that's 0 decimal. All of them on, that's 255, and that's how the byte works and how our information gets sent. Now, how about negative values? How do we deal with negative values?
So essentially, there's 2 ways you can deal with negative values. There's the sign bit, which is if you're sending a 1 byte value, it's going to be your most significant bit. That most significant bit will be your negative flag, and then the other 7 bits will be your actual value.
So when we're decoding that, we look at whether that status flag for the negative is on or off, and that will tell us whether it's a positive or a negative number.
Yeah, and you have to count backwards by doing so. So for instance, if you have a value of 0 in a 1 byte message, you would have a bunch of bits being 0, 0, 0, 0, 0, 0, 0, 0. But if you have -1, you would have 1, 1, 1, 1, 1, 1, 1, 1. And the most significant bit, that first bit, is your flag to say, hey, it's negative. And then you have to count backwards, basically from 0 to figure out where you're going. So all the values essentially roll over like it's a scoreboard going to 999, and you go backwards. So -1 would be 999 on the scoreboard. -2 would be 998, things like that if you were looking at it in a decimal form.
Okay, so that's very different to just flipping that status bit on or off, and the number flips from positive to negative. The whole number has to change.
That's correct.
Okay. All right, so that's one way. How else can we represent negative values?
I typically, you can also offset them. So essentially, if you offset a value, you can say, hey, we'll say our 0 is realistically, let's say -40, right? Or -100.
So this is your temperature example before.
Right. Yeah. So you just say, okay, well, set 0 as -40 because we offset it by a value of -40, and let's just start incrementing from there. So if we have a value, a raw value of 40, we really have an actual value of 0.
Yep. Yeah. Okay. Now this sort of brings us into how the data is actually coded and decoded, because if you're sending coolant temperature, for example, for that very reason, you're looking at the data. It's not going to read, 82 degrees C, for example. It's going to have that offset in it, but it's, you're looking at hexadecimal values. The example actually will probably be easiest to come back to is our throttle position. So obviously, throttle position, we want to see 0 to 100%. That's what our brain is programmed with. But what we already know from our little example there is that actually when that byte is a value of 255 decimal, that equates to 100%. Now, that's really easy. We just divide it out like we did, and we know what we've got. But when you start adding an offset in as well, that gets a little bit more complicated, and then we can also have multipliers and dividers. So I guess for a start, why can't we just send the data and the raw numbers that we actually want to see?
It's a little bit on the computer science side, but essentially data types, that the computer expects to see are, they're not necessarily human readable information, right? And it is encoded in a specific way that the computer understands it. Now, as humans, we don't typically talk like computers or think like a computer for the most part. There is some exceptions, I guess, for some people out there, but you're typically thinking, all right, almost all your values are going to be in decimal form. We don't typically think binary. We don't typically think hex. And that's a little bit of the challenge associated with, kind of understanding or decoding this information in regards to what the information is versus what the information is expected to be to a human.
All right, let's just come back again to my little throttle position example. So generally when we've got a device that's able to decode CAN messages, and we've got control over that. As I mentioned there, we'll have maybe a multiplier, divider, and we might have an offset or an adder. So for the throttle position example, I didn't really go through that in full detail. So we know that the value that we're seeing is 255, and we need to make that equal 100. So how can we do that? Well, we divide it by 2.55. But generally, we can't use decimals. We're using integers. So we have to divide by 255, which is then going to give us a result of 1, which isn't what we want either. So then we bring in a multiplier as well. So we're dividing by 255, multiplying by 100. Now we've actually decoded that message. So 255 is going to represent on our screen as 100%. We don't need an offset or an adder for that particular output, but obviously for a lot of them we do. I want to go a little bit further into your process of actually decoding data, because hopefully that little example there is just showing that it's not necessarily always straightforward. And the first question I've got is, what hardware and software do we need to actually go about reverse engineering a CAN bus, or sniffing a CAN bus as it's referred to?
Yep. So you're going to need essentially, I want to say the easiest way is a CAN to USB adapter of some sort. There's plenty of them on the market. Anybody that's starting, my recommendation is a peak pecan USB. There's plenty of offerings and knockoffs on the market. You're going to be challenged at some point with it operating, with the knockoffs and things like that. So I tell people, start with a known standard, and the known standard is a peak pecan USB. It's supported by many platforms and structures. It actually works with the ECU master hardware natively if you want to use it. So you don't have to use the ECU master CAN to USB alongside with the peak pecan. If you have both of them in your toolbox, you can just use the peak pecan. You don't have to worry. But yeah, peak pecan USB with pecan viewer software, so you can analyze and log messages and create log files if you need to review later.
Okay. So when we're looking at this data, again, when we're fresh to this, it's very confusing because we've got our addresses down the left-hand side and then 8 bytes of data. Typically, we'll probably look at this in hexadecimal values. And again, these are meaningless numbers. We're not seeing our throttle position or our RPM. So let's say you want to find oil pressure, and let's assume this time that oil pressure does in fact exist on the CAN bus. How would you isolate that out of what could be hundreds, if not thousands, of different messages?
Well, there's 2 ways to do it. There's looking at the data when you know it would be changing. So I always tell people, you want to be in control of, if it possible, the min, the max, and the ability to change it. Now with oil pressure, it's kind of a challenge because you don't have a starting point. You have a starting point of 0, so to speak, when the engine's not running for the most part, if the car's set there. You don't know a max, right? Because you don't know how high it's going to go. And you don't really have the ability to control how well it changes in a grand scheme. Like, you don't have direct control over oil pressure. You have the ability to increase oil pressure by increasing RPM, which would effectively create more oil pressure, but you don't have the ability to control it directly. So you're going to take the node and go, okay, well, what we're starting with 0, starting with the engine off. If we have data that's changing all over the place while the engine's off, well, I can eliminate that as possibility, right? That's not going to be it. And then I'll go, okay, well, let's start the engine and see what's moving. Okay. If the numbers are holding stable, if they're not moving wildly, once we have it warmed up and stuff, okay, there we have a possibility, and from there it becomes largely a crime scene to figure out to plausibly exclude various bits of information. It's not for the faint of heart, but you are able to do it. It's not super challenging. It's methodical.
One of the ways, just to add into that I go about that, and I admit I don't do nearly as much as you, with some of these signals you might be looking for, a real good place I find to start is just unplug the sensor with the engine running. And I mean, that might end up causing some unintended consequences. Probably at idle, you're not going to do any damage to anything by doing this, but coolant temperature, unplug the coolant temperature sensor and see what piece of data, what message actually changes, and then plug it back in. Does it come back? Okay, that's going to allow you to probably quickly zero in on that particular sensor. Can't do that with everything, obviously, and if we're looking at messages going between maybe a TCU and an ECU, that's different as well. The next obvious question, and you kind of referenced this with the oil pressure sensor, if you don't know what the value is supposed to be, how do we go about decoding it? Basically getting that multiplier, divider, and offset in order to turn that raw value into our oil pressure in PSI or bar.
Usually, I mean, I try to find any references I can, whether it's the dash, if it's an OE application, potentially a scan tool. If I'm looking at information on a scan tool and it says, hey, like the oil pressure is at this value, and I think I have it, so I'll increase, do something to induce it and increase, and do something to decrease it, and then just kind of map it out and say, hey, like this said it was this pressure at this, at this raw value, and then just go, okay, let's see if we can create a correlation map, and if we can get it to correlate, all right, and then also if we can't get it to correlate, and I can isolate that message or eliminate that message on the network, but still send that message with the peak beacon, maybe, just maybe, we may see that information on the dash.
Yeah, I think scan tools or a dash are a really powerful way. And essentially, as long as we can kind of get two data points, hopefully separated by a reasonable range, that's going to be enough to decode it. On top of that, you can also use, as you mentioned there, some of the sniffing software to actually send a message out specifically to test that you've got the value where you want it to be. So there's a couple of ways of going about it there. What are some of the techniques though with the more sophisticated data, like I mentioned there, maybe torque values between TCU and ECU? Is that going to require some OE data on how they've encoded it?
Yeah, I always recommend it when you're getting down the rabbit hole with torque and torque values. Almost every circumstance that I've seen torque values on, the scan tool can be applicable to the circumstances. So I say use your tools to to reference information. So if we have torque values and we see the torque values being supplied from the engine controller, from the transmission controller, a lot of those numbers don't really add up. Like if we went and set the car on a dyno and said, hey, what power is this making? And we look at what the dyno says, the information actually doesn't line up, because the manufacturer does their own thing and they can say, hey, we expect it to be this number and we set the calibration to be at this number. It's not actual. It's not precise to the degree, which makes it a little bit of a challenge. But it would be tools to use and verify the information that you're seeing correlates to the torque value increasing and decreasing over time.
Sure. I'm guessing it's not possible. Most OE manufacturers aren't going to make detailed accounts of all of the CAN messages that they send and receive publicly available. They don't like us getting hold of that sort of information.
Man, I wish that they were a little bit more graceful on offering it. Usually it has to come out of the back door of some engineer that's scorned. Unfortunately, there has been circumstances where information is supplied, and it's because of the OE at the OE level, with certain people. And if you build those relationships and learn who they are, they might help you out a little bit. But at the end of the day, yeah, the OE manufacturers aren't just publicly offering this information in any regards. It's they don't want you knowing, they don't want you working with it, they don't want you assessing their information for, I believe, a handful of reasons. Because if there is a problem with your car, you can kind of call them out with the data if you knew that it was accurate, right?
Yeah, sure.
But it's also if from the warranty aspects, if you know how to manipulate it as well, now it may be a little bit of a warranty claim that they have that they shouldn't have.
Yeah, fair play. All right, let's move on to a product that you've actually created yourself, which is your CAN gateway. I'm interested to sort of, first of all, understand where you saw a need in the market for this. And I guess we probably should actually preface this with what is a CAN gateway?
So a CAN gateway is essentially a device that can manage and route messages or information on any CAN bus or essentially any device or peripheral associated with it to manage information on more than one network, right? So if you have information that needs to get from point A to point B, but they're two separate networks, a gateway could provide a link between one bus or one CAN bus or network and another. And then, there's more you can add to them, and they can take substantial steps into deeper layers to almost become body control modules in the grand scheme. But they offer the ability to route and transmit information from point A to point B in various regards.
I think for me, the powerful aspect of this is being able to interface two devices that are not user programmable and make them talk to each other. So good example of this is one of the challenges, I guess, with any late model car now. It's becoming increasingly difficult to replace the factory engine control unit with an aftermarket standalone, because you probably get the engine running, but the dash cluster won't work. Maybe your aircon won't work. The automatic transmission absolutely won't work, because all of the messages that those individual units I just mentioned that they were relying on is no longer there. The aftermarket ECU can't send it out. But maybe it can. Maybe just about any modern ECU now has CAN buses on it and can send the data that's needed. But if it's not user programmable in terms of the address it's going to send out, RPM, and the way it's encoded, then we're still back to square one. So with your CAN gateway, we can take, let's say, a Haltech ECU with its generic template that it would send to a dash, and then you've got your RPM and your coolant temperature. You can then pluck out those individual pieces of data in the CAN gateway and essentially shuffle them around and send them out on different addresses and coded differently.
Yep, that's absolutely correct. Essentially what drug me down this rabbit hole is I bought an E55 AMG back in 2015, and I believe I reached out to you and I was like, hey, like this thing has a lot of CAN information and nothing met the needs on the market for what it needed via CAN. So like if there was a circumstance where an ECU said it had CAN capabilities to send information, I was limited on the approach of how much information it could send. I needed 16 messages to be sent. And at the time, I think Link had 8.
So what are you trying on this E55 AMG to put an aftermarket standalone on it? That's the...
Yeah, I was trying to put an aftermarket engine management system on it, and everybody told me, you can't do it. It has a CAN bus. You're not going to figure it out.
Challenge accepted.
Yes, absolutely. Challenge accepted. Let's dig into this. And so it drug down this rabbit hole. I didn't know what CAN was in the grand scheme outside of a communication model from the get-go. I was like, I'm not going to let it kill my goal. And so I started, researching what is CAN? What does it have? What can I use to analyze it? How am I going to get, the information from the OE box into another box to make everything work? And I kept digging down this rabbit hole. And every time I would find a solution, it was either outside of my cost, it was too cost prohibitive for me to try, or it didn't meet my needs of what it had. So I ended up having to go, okay, well, let's just build my own thing, right? I needed to control various aspects. And if I'm building it myself, I only can, if it doesn't work out, it's on me. It's not on anybody else. I didn't have a salesman giving me all the check boxes saying it'll work. It's me. It's my problem now. And that's largely what drove me to build my own CAN gateway.
I guess the question obviously is, did it work? Did that E55 AMG run on a Link ECU?
No, unfortunately not. I sold it when I bought a house back during 2020, and it never came to fruition. Now, with that being said, I do have a contract that I'm working on that's 2 of the similar applications that they have approached me with because they saw my abilities and skill set. So I may end up making the dream come true, just not on my own car.
That aside, it's not through a lack of capability. It could have been done, just the stars didn't align at the time with that particular vehicle.
That's correct. Yeah, it was a situation where I had the ability to sell my car, offload a bunch of equipment, to transition from one house to the next. it just wasn't my time at that moment. And I let the dream die, obviously, with selling the car, I guess, in some regards, but I never let the dream die on what my goal was.
Sure. All right, just something that popped into mind while we've been talking here, and this might be a little high level, but I'm interested just to get your take on it. How do you approach maybe something with a modern DCT gearbox or auto gearbox, which is very reliant on accurate torque output from the engine control unit into the TCU? Now we're going to get rid of the factory ECU and we're going to put in, let's say, a link ECU, something that's not torque based though. So it doesn't natively have an output for engine torque that can be translated through the CAN gateway and sent to the TCU. So now you've got two problems. You need to encode the data to send it to the TCU, but you don't have the data to encode.
Yeah. So essentially, everything that I tell people, all the information via sensor signals, if you're doing an OE integration project, it was largely already there from the get-go. While the aftermarket engine controller may not supply said info and package it up for how you need it, they made a characterization based on some parameters. And for instance, like torque, it's going to be based on a handful of scenarios, but for the most part, you have airflow, you have VE, and you have your lambda values and your ignition timing pending it's at its optimal place. So if you can figure out where your ignition timing is optimal and see if there's any timing, retard, your airflow and your VE and your lambda values, you can essentially make a decent calculation and come up with your own torque value to supply to it.
Okay. And how's that going to be done? Are you going to do that essentially in the ECU, maybe with some auxiliary tables to output something near enough, or are you going to rely on something else out of the ECU that already does natively exist, let's say airflow or volumetric efficiency, and then do some clever coding inside of your CAN gateway, which I don't even know if that's possible. I'm reaching here.
Yeah, it's absolutely possible. And this is where I say that the possibilities are up to, typically I try to say it's up to the end user. How do you want to do it? Do you want to have it to where it's able to be adjusted and edited inside your standalone unit, which is typically what I recommend, at least in some manner. Let's have a table build the table up based on two axes with airflow, ignition timing, retard, if anything, and determine from there what we need to add to it and do some type of factors on the back end if necessary. Your lambda values obviously aren't going to change drastically on power over time. So like if you have, 0.92 is going to say 90% of your power based on wherever you're at. And, lambda 1 is going to be a value a little bit lower than that. And as you go scale up, you're going to have a little bit lower value on output. So we can say, hey, take the static values, put them in the gateway, but take all your dynamic factors that you're going to be changing drastically. Go ahead and add those in the tables inside the ECU if possible.
Yeah, it's always nice to be working in just one location when you're doing a calibration, rather than have to modify the calibration, then also access this CAN gateway and change whatever's going on in the code there. I think it's probably also worth mentioning that quite often you don't necessarily have to be pinpoint replicating the original torque value. There's almost certainly going to be some leeway. So if you're out by, maybe 10 or 15 Newton meters, probably you're not going to smoke the clutches in the gearbox. It's probably still going to change gear. But if you're starting to get 100 Newton meters away, probably that's the TCU is not going to be happy with that, and it's maybe not going to change gear, or something else is going to go badly. All right. So I guess the next part of this conversation is how do you actually control and program this CAN gateway?
So it's step into the lion's den for most people, but essentially I had the option of, graphical user interfaces and what the constraints are associated with them are. And the struggle I always had was I can always think up something else needed, right? I can always think of, hey, like we need another table, or we need another address. We need this or that. And I want to control it in this specific manner. So I left it to be like programmed in C. And that gives essentially the end user or the programmer complete flexibility to do whatever they need to do, whether good or bad, with the box. If you're ever considered in a situation where you have to, consider, hey, like I could do this with, another gateway that, of whatever manner with a graphical user interface, At some point, I expect the graphical user interface to run out of limits. Now, the limit that I have, everything has limits. The limit's essentially memory for me. It's not how many messages we can supply. It's not, how many tables we can provide. It's just how much memory do you have available to use. So it isn't the most refined for the end user if they're not from a development background.
Yeah, I would think that would sort of take it off the table for maybe 80-90% of the population. I mean, I'm out. That's beyond my skill set.
Yeah, I knew that use case coming in, but I also knew, where does every box fall short, or what does every other gateway fall short in the manner? So my goal to check the box was, where everything else can't meet expectations, I want to be able to meet them.
Sure. I mean, this is probably getting a little off course, but while we're here, would it make sense for you to offer sort of a standard and then a pro variant, the standard with the graphical user interface, and then, for those niche cases where that becomes a limiting factor, step up to the pro, learn to code and see?
Yeah, it is something on the table. I haven't taken the initiative to build a graphical user interface just yet. I'm probably going to end up implementing additional hardware to offer more features, because people have said, hey, I want some analog inputs. I want some digital inputs. I want some additional IO outside of CAN to run on it. And so from that aspect, I'm like, okay, I need to take all of these ideas that people have said, hey, yeah, this is good, but it's not great, and build the next iteration to make it greater than the first.
Do you think, I guess, when you're getting suggestions like this for features, what do I find, particularly, I've done some sort of consulting work for some of the ECU manufacturers in the past, and as a high-level user, it's very easy to say, hey, I want this feature here. I think this would be a great feature. And on face value, I mean, it makes sense, this little widget that someone's asked to add. But is that widget going to be worth adding? Because is that actually going to be useful to the 95% of people that are going to use the product? So where I'm going with this is, how much value or weight do you place on these requests people are asking you for versus your own understanding of the product, the market, and what people actually are using? Caveat for that is, clearly, if you're starting to get the same request over and over again, well, obviously that does make sense. But yeah, I'm interested in your take on that.
Yeah, you have to vet feedback, right? Because not everybody is going to have a great idea that suits everybody. But you are right. The next iteration I will be providing FD support for, because of the C8 vet, because people are saying, hey, I want to run an aftermarket data acquisition system on my C8 vet, but it runs on CAN FD, which is not necessarily the most compliant to CAN 2.0. So everything's built on this current standard, but this, superseded standard is what the C8 Corvette's running. So it puts it into this little hard place on how people are going to acquire data from it. But yeah, you have to just take the approach and be like, hey, I can think about it. I'll look into it and see what we can do. But yeah, not everything's going to make it to production, obviously. And, you have to sit there and say, well, is the juice worth the squeeze too? Right. Because, it's easy to say, hey, I want a box that has, unlimited, memory, processors blazing fast, everything under the sun. It's like, yeah, okay, well, do you want to buy, something that's 30 times more expensive, or 50 times more expensive than it currently is, just to meet that expectation? And most people usually have to take a step back and dial it back once you get them to that point.
I think that the other problem with user-generated feedback or suggestions is, quite often people will use that to kind of flex their level of knowledge in the industry. I want this really extreme feature. Look how clever I am. But the reality is, like, no one, including that person, is probably going to use it. So there's a bit of filtering required. Now, you just mentioned CAN FD. So everything we've been talking about so far is essentially CAN 2.0. What is the difference? So first of all, what does that CAN 2.0 mean? And then what is CAN FD?
So CAN 2.0 is essentially the current generation that we've been using since, I think, 1992. It essentially was the first iteration that actually really took off. Prior to it, it was essentially Bosch's like R&D stuff and stuff in the 80s. So you don't really see that at all. CAN 2.0 is what we use today, and what you see on most of the motorsports applications and almost all of your aftermarket engine controllers and things like that. CAN FD is the successor to CAN 2.0, and it runs essentially, it can run up to 8 times faster right now. So if you can fit, like, let's say 8,000 messages of 8 bytes in length on the current standard, you can fit 8,000 messages of 8 times 8 bytes in length on CAN FD. And that's pretty much it. It just tries to add another layer to offering more bandwidth.
Right. So that was going to be the next question. Is this a bandwidth problem or is it a speed problem?
I personally think it was neither. I think it was just the industry standard calls for wanting more, and they finally gave in.
Okay. Yeah. I mean, I think it is fair to say, though, that as things become more complicated, that the bandwidth does become a limiting factor. I have this exact scenario on our 86 Endurance car. We essentially use, and this is actually an interesting analogy to your product, we have a variety of electronics. So I mentioned earlier, we've got Motec ECU, Motec M1 ECU. We use a Motec C125 dash, and we use ECU Master PMUs, but then I've also got a lot of Izzy Racing CAN-based sensors. So I'm essentially using that C125 dash as CAN gateway because it is very user configurable in terms of receiving and transmitting CAN messages. So a lot of flexibility there. So when I want to interface something, for example, we have an ECU Master CAN switch pad on our steering wheel. So all of the buttons, knobs, etc., the paddles all go into that. It's wireless. And then that can't, the upshift paddle, for example, cannot be read directly from the Motec M1 ECU, which is ultimately where it needs to go. So that gets decoded inside of the dash, and then it gets transmitted back out to the ECU in a mode or in a way that the M1 can understand. And then all of a sudden, we can change gear again. So that coupled with, I mentioned the Izzy Racing sensors, we've got internal tire pressure and temperature monitoring on all 4 corners. Then we've got external 16-channel infrared tire temperature sensors. We've got 3 laser ride height sensors, and those transmit at 1 kilohertz. So we're actually at a point where our bus utilization is kind of getting a little bit scary, sort of 85 to 90%. And then, of course, we get into the problem of messages starting to drop away. So I think bandwidth is definitely a problem. Yeah, I've got 2 buses on that vehicle, but for a variety of reasons, I have to have a bunch of that on one bus, and then, you're sort of at the limit of that bus. So I'd like a little bit more bandwidth.
Oh, yeah, absolutely. Yeah, as time passes, obviously, more sensors, more data, more everything is going to come.
Before we started recording, we were just talking a little bit about where you place the data in terms of addresses versus importance. And I think that would probably be good to bring up here as well.
Yeah. So I always try to make sure the more critical of information is always at a lower arbitration ID. So the arbitration ID will control, if we have 2 messages trying to send at the same time, which one goes first, right? So if you're running to the line at Walmart for Black Friday specials, if you have a lower arbitration ID, you get to check out first. I always put the critical natured items at the lower arbitration IDs and start working my way up. And most of your manufacturers actually do this too. They have a very methodical way of setting information up. So for instance, your powertrain information, your engine controller to your transmission controller is typically at a pretty low arbitration ID. And then from there, if you have things like coolant temperature or tire pressure, so to speak, on your OE application, it's a little bit higher on the bus.
Doesn't really matter if that message drops off occasionally here and there.
Yeah, absolutely.
I think that would probably go for ours as well. I probably don't mind if I miss a few bits of data from a laser ride height sensor, but I'd really like to know that when I pull the upshift or the downshift paddle, that data is going to go through.
Yep. Yeah, I always try to push, if anything that has the highest, the most critical response time first. Like that is going to be the utmost important. And then errors in error handling second. And then from there, just kind of go by priority and to say, hey, which one sounds more important? Does your air temp sound more important, or your tire temperatures, things like that?
All right, makes perfect sense. All right, back to CAN FD. So this is sort of an upcoming potential protocol that's going to be used. How mainstream is it at the moment? I think you mentioned the C8 Corvette. Is it in a lot of vehicles at the moment?
Yeah, it's coming around. The 2019 and up global B trucks, so your Chevrolet full size vehicles are now running CAN FD at least on one of the buses on the vehicle. Your C8 Corvette's probably the most notable, but you also will see it in Mercedes, Aston Martins. A lot of your luxury vehicles have been running it for a few years now. And it's going to be the successor at some point once these cars kind of start getting into the limelight of the street scene, I guess. You'll start seeing, hey, the need for an FD gateway to FD CAN 2.0 will be need to be filled.
I only assume that's going to also trickle down into the aftermarket electronics industry as well. Am I right in assuming that this isn't just a rewrite of software? This is a hardware change to go from CAN 2.0 to CAN FD?
Yes, it is. It is a hardware change as well. There's essentially a controller and a transceiver. The controller is different. The transceiver is also different. So it's not just something that can be, yeah, I whipped up some programs. If the hardware was already implemented in the device, yeah, it is a little bit easier to do. But yeah, it's gonna require a new iteration of hardware to come out at some point and to fulfill its desires if it hasn't already been implemented. There's a lot of devices that may have it already, but it's just not being utilized because they don't need it yet.
Sure, yeah. In terms of other up and coming protocols or communication techniques, another one that I know very little about, but we hear about occasionally is FlexRay. Can you fill us in on what that is and how relevant that is?
Yeah, so FlexRay is essentially it's a 4-wire protocol that is a little bit more challenging than CAN FD. I don't expect it to take off. I think it's a very niche protocol that was offered before CAN FD really took off. BMW really invested on making it the next standard, and I don't think it went very well for them. But it is there. You'll see it on a handful of vehicles and applications. They'll use it, and it's more of a timing model. So you end up with information have suggested slots. So every, let's say, second, a device has they slice it up in time, and each device can talk within that second for a specific amount of time to say, hey, this is the information we can provide, and this is what we got. And then the next, if it goes from engine to transmission to body control module, and then goes back in a circle, they have this round robin event of information being communicated. So there's no arbitration phase for it. It's a timing model that it knows it's your turn to talk, then it's your turn to talk, then it's your turn to talk, and then we can proceed on over again.
Okay, yeah, fair. I guess when OEs are sort of having these battles as to what the next big thing is going to be, it's sort of, I guess, like the CD, the cassette tape, and now we're just streaming music. There's all these technologies that come through. Some of them take off, and some of them fall short. So to be expected, essentially, from what you've explained, I can't really see in the current model why we would need anything more than CAN FD. That's got to have everything pretty well covered, I would think.
On top of that, I think licensing fees as well as the hardware to implement is what's going to prevent FlexRay from being the next big thing, because the hardware is much different than CAN FD. It's much more costly as well.
Okay. That's a stumbling block for sure.
Yeah, it definitely is going to if it increases the cost across the board. At an OE level, if you're building a million units, do you want to spend a million units, at 4 times the cost versus CAN? So there's some definite challenges associated with it that may end up stopping it in its tracks.
Okay. Now, sort of coming full circle, one of the reasons we decided we should get you on the podcast is after our interview with Tuned by Sean, and I know that you two had been sort of collabing on some plug-and-play kits that he's now providing for the likes of the C6 Corvette using a Haltech ECU and your CAN gateways. So I'm just interested, when you're looking at these newer vehicles, you've got obviously CAN FD we've talked about coming through, things are getting more complicated. Is it going to just continually get harder for the likes of yourself and Sean to be making these plug-and-play kits for these later model vehicles?
Yeah, it's certainly not getting easier, especially as time passes. Back, I want to say 10 years ago when they were building vehicles, and prior to that, there wasn't a lot of, stumbling blocks associated with information just being sent. So if you could send, engine speed, RPM, whatever the dash needed to read appropriately, the car would it'd be pretty much fine with it. Up until about, I want to say about 8 years ago, you'll start seeing that they have added more information to basically, like, I want to call it secret information inside the message itself, to know, is this message actually correct, or has somebody just tried to emulate the information. We put we call it checksum, or a kind of like a math calculation that's recursive to the message into it, that adds challenge to it. And then, if you keep going to what's being built today, there's a lot of initialization sequences on various applications that say, hey, I'm going to send you a whole paragraph of information. And if you don't send me back a whole paragraph of information that's correct, how you got your password, we're not going to start. We're not going to work. It's definitely a challenge.
Not one that I look forward to, but I have confidence that there's some incredibly smart people like yourself in our industry, and when it comes to being able to access and reflash these current generation vehicles, there's a very big market with a lot of money to be made, and that's a really powerful driving factor for people to kind of figure it out. And then, as you alluded to earlier, often there's sort of some backdoor information coming out of some of the OEs as well that possibly shouldn't be shared with the aftermarket, but we know that does tend to happen from time to time.
I wish it happened more often, to be honest. I would be more on democratizing the information than hiding it. But I understand why they do that, because they don't want their cars stolen. They don't want a lot of warranty claims for people, basically voiding the warranty of the car and then putting it back to stock and then taking it back saying, hey, I got a hole in my block. I don't know why. Here you go. It's under warranty. It's got less mileage and time frame. So
no, I can totally see the reasons to try and lock it down, but we on the other side of the fence don't want it locked down. Coming back to that C6 Corvette project with Sean and using the Haltech ECU, could you just give us maybe a couple of ideas of what were the biggest challenges on that project?
So doing remote analysis is always a challenge, because you're not there. You're essentially looking at a log file trying to understand what's going on, right? And not only are we looking at a log file, we're not looking at a log file that actually has information supplied in any significant way. So you go take your car on the track, go drive it around. Hey, what the information being supplied is. I'm just looking at a bunch of numbers and trying to make sense of it. So you got to tell them, hey, as me to Sean, I have to say, hey, I need you to go do specifically this task, and then provide me as much context as possible on doing so. So like, hey, I need you to go take this car. I want you to go to 55 miles an hour, and I want you to hold it at 55 miles an hour for 1 mile. And then I want you to pull over and stop immediately. Things like that, because I need to have those standards of where this information would have been held for that period of time, how he stops immediately to know, we're going back down to zero. So I have reference points of it. So getting the reference points and communicating the reference points to understand what exactly is going on remotely based on asking somebody. So it's almost like if you're a service advisor at a car repair shop, like, hey, what problem are you having? But I need as much detail as possible. And so a lot of the customers are saying, well, I hear this clicking sound when I'm going 30 miles an hour when I'm on the road. It's like, well, what kind of clicking sound are you hearing exactly? Those things you have to really dive into to understand, because you're not, you can't use your senses to have any understanding. I just got to use essentially my brain and my eyes, and that is it.
So it would have, in fairness, been much quicker and easier if you were on site doing this testing yourself.
Oh, absolutely. Absolutely. 100%. And that's not a knock on anybody. That's the nature of the beast. If you're trying to remotely diagnose just about anything, unless you have a very, very high level understanding of the information that needs to be, addressed, and the issue is well defined, you would rather be there firsthand.
Of course. All right, I guess the proof is in the pudding, though. This conversion that you two built, this plug and play kit, does it do everything just like OE, or is it missing anything? You give it to someone, would they know that they're driving a C6 Corvette with an aftermarket ECU in it?
So nothing to my knowledge is missing, but I always tell people I don't know what's missing at all. So, but given the circumstances that we had, everything that we had on the table, all the check boxes for, information, whether it was traction control levels, all the dash functionality, everything works as it should. And we haven't had any hiccups whatsoever so far, and I hope that maintains the case. But there's always that level of question that oh, did I miss anything? Did I not add what I needed to? Is there something else that I could have gotten? And truth be told, it used to eat me alive, but nothing there that I'm aware of that we are missing. And truth be told, if there is something that we find that's missing down the road, we can always add it back.
Yeah, that's a good point. I think it's fair to say that you can always expect maybe some weird situations to crop up that actually then show out that maybe something was missing that you couldn't see under normal driving circumstances. But like you say, I mean, you find these problems and you fix it, you add them in. So often a bit of a work in progress, but obviously sounds like, suffice to say, 99.9% it's doing exactly what it says on the label.
No, that's correct. And I've reached out to a handful of ECU manufacturers. We all deal with this. Hey, I had this special edition that had a specific message that would prevent the car from starting. And we didn't see it anywhere else but this, 25th model, vehicle.
All right, Mitch, I think we'll move towards wrapping this thing up. I want to respect your time. And as always, we've got the same three questions we ask all of our guests. First of those is, what's next in the future for you?
Man, I am working on the successor. I'm taking the feedback that I'm getting. I'm trying to create a better training model to help people understand, because I do want to have offered solutions to people that if you're determined, you can do it. No, I don't want anybody to say, hey, like, I just don't know enough about programming to do this. Well, let's learn programming. Let's get you up to speed. It's not challenging. If you're willing to take on this task, I'm willing to bet that you have the knowledge and skill set to learn what's needed. But yeah, offering a successor, adding KNFD to my gateway so I can implement it into the newer vehicles. So if they need a KNFD, they can have it at will, and I don't have to say I don't have that yet. But adding a little bit more IO as well. Not that I need the IO, because I typically tell people, they're like, hey, I want to add more, analog inputs. And it's like, well, what are we replacing by doing so? Because chances are you're already replacing some IO expander and you're just trying to mesh it all into one box. Well, I'm not mad about that, but there's already a refined product there. I want to solve problems that no one else has on the market yet.
Yep, that makes sense. I get it. All right, next question. Is there any advice you give to a younger version of yourself to help reach where you are today in your career faster?
Yeah, outside of never stop the curious mind. Always be curious. Always try to dig for, answering questions, right? Because that's largely what's driven me down to this knowledge hole that, people say I'm a so-called expert, right? And I don't ever look at myself as an expert, because there's always more for me to learn and understand. And if you just give up on that curiosity, it'll kind of like drag you down. You're not going to excel. You're not going to grow and build relationships with people in the industry, because you never know when they're going to come in handy. There's been times I've been struggling with a circumstance, and, I'll just like, oh man, I just can't figure this out. And then next thing you know, I have somebody that's, contacting me saying, hey, I got information on that. If you need it, here it is. So everybody in this industry, we struggle with stuff a lot behind the scenes. And a lot of us, we want to make this highlight reel and curated, scenario to say, hey, like, everything is great here, but we all have challenges and we all know it, and if you've been around it any long enough, you know that there's some car that's just kicking our tails, and we just can't solve it, or we just have a dilemma that we can't overcome in whatever way that is. And it's okay to embrace that headache.
Yeah, you're absolutely right. The Instagram highlights reel of everything's rainbows and unicorns is definitely not real life, and there's always the struggles behind the scene. I think the curious mind is a good one. It's why I'm still really passionate about what I do, is because there is always something new to learn in the industry. And yeah, again, the further you get along the Dunning-Kruger sort of curve, the more you know that you don't know, the more you realize there's still that body of knowledge to learn. So yeah, I think that is really important. Closing down your mind to that possibility brings nothing good at all. All right, our last question for today, Mitch. If people want to follow you, see what you're up to, maybe purchase one of your CAN gateways, how are they best to do so?
Yeah, my website's mintonperformance.com. You can send me a message there, or if you want to find me on Facebook, it's just Mitch Minton. Almost everything else, social media, I don't try to keep up with, because I found it found it too challenging to, manage 4 different apps all doing the same thing for the most part. So, I have an Instagram, it's dormant. I have a LinkedIn that's also pretty dormant. I've never got involved in anything else, TikTok. And, and I also have a YouTube channel, Minton Performance, that I try to post, the nerdy tech details on explaining things and stuff like that as time passes. And there's a lot of great information on it. And I get a lot of feedback like, hey, this, you taught me how to, use this software in a specific manner that I didn't know before. Most of it's typically motorsports oriented. Sometimes it's, nerd oriented, but for the most part, that's where I go to, is YouTube and Facebook.
Okay. Well, as always, we'll put links to those in our show notes to make it nice and easy for people to find. Well, great to chat today, Mitch. It has been ages, so I really appreciate you taking the time out to chat with us. And hopefully everyone's just a little bit more clued up on CAN. Hopefully we haven't sort of managed to just confuse. But yeah, thanks again.
Thank you. And if they do have any questions, feel free to reach out.
Perfect. I hope you've enjoyed this episode of Tuned In, and don't forget, by using the code podcast500 at checkout, podcast listeners can get a huge $500 off our VIP package, which includes over 40 current courses, as well as a long list of courses to be released in the future. As a VIP, you'll also get lifetime access to our members-only webinars and our community forum. Lastly, we'd love it if you could leave a review or comment on your preferred podcast platform. Your feedback really helps us to reach a wider audience, which in turn allows us to continue bringing you more high-quality guests. As a thank you, each week we'll randomly select a review or comment from Spotify, Apple Podcasts, or YouTube and send the winner a free HPA t-shirt shipped anywhere in the world. It's also a great place to ask any questions you might have too, and if your review or comment is chosen, I'll do my best to answer them directly. So this week, a big shout out to Jeff Jin, who has said, I absolutely love your podcast and the wide variety of guests you've hosted. It has really expanded my knowledge, which I've been able to apply to my car. Well, great to hear that you're enjoying the podcast and you are finding ways to apply the knowledge you're learning. If you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.